Hi gents, introduction to statistics. Kind of learn outcome to discrete continuous data. Mean for Ungroup data, which I would have thought you've all done the work as revision. Deviation, group discrete data. So let's see if we can get through all that this morning, hopefully. Alright. So, discrete and continuous data. Discrete data is that obtained by counting. For example, the number of red cars, green cars, etc. in a car park or travelling down a road. And we can present discrete data using a histogram. Yeah. So that's just how many of a particular item against another item, against a third item, fourth item, and so on. Continuous data, on the other hand, is data obtained by measurement. For example, the length of bolts in a box of bolts, speed of a range of different cars, etc. Right. So they got definite values, and they can be anywhere between two limits. Presentation of continuous data requires that the data is grouped into frequency distribution and then displayed using histogram. So what we'd normally do is have the heights between two heights, count them up at a frequency, so you would group your data into group sizes as opposed to single values. Everyone happy with that? Have you come across that before? Schoolwork? Yeah. Another way to present group data is to take the mid-class value. So each group is called a class. Take the mid value of that class, and you draw straight lines between the values, and you create a frequency polygon. So that's another way that you could represent the same data, and that is representing the same data as the histogram on the previous page. Well, no, it isn't. But anyway, that's an example of. Alright. Worry too much about graphs at the moment. So, moving on then. Mean, median, and mode for ungrouped data. Okay. Mean, median, and mode are all really what's called measures of central tendency. Another word for mean is the average. Okay. The arithmetic mean of a value set of data is found by adding together the values of that set. So we've got a data set, all our values. We add together all those values and divide it by the number of values in the set. Sure, you've all come across that before. We're talking about ungrouped data here at the moment. So we just add 4, 5, 6, 9 up on the top line, divide by the 4 data points in the set, and we get a mean of 6. And a general expression, we use this X bar symbol to represent the mean of the set of data values X. So each data value is X1, X2, X3, and so on. The top line there. The number of data values there is N, and so we use this Greek capital letter epsilon to mean the sum of all the X values divided by N. Sigma. Alright, all happy with that? And remember that X bar is too far. Yeah, all good. Median. The median value often gives a better indication of the general size of a set, central tendency, if the set contains extreme values, one way or extreme high or extreme low as compared to other values. So we take the set 7, 5, 74 and 10. If you calculate the mean of that, you get 24, which doesn't really reflect the tendency of the values in there, if you like. Okay, so you might choose to use the median. The median value is obtained by ranking the set in descending order. So we have to put them in order and select a middle value. For sets with an odd number of values, the mean of the middle two halves for the set. So if you've got this, you take the halfway point between 7 and 10. So you add the two together, divide by 2. So that's got a median of 8.5. Alright? Show that, I'm pretty sure medians in the GCSE as well. The mode, no, the modal value or mode is a frequently recurring value in the set. So again, it can be chosen as a measure of central tendency away. If two values occur with the same frequency, the set is said to be multiplying modal. So if we take that set 5, 6, 8, 2, 5, 4, 6, 5 and 3, the modal value is 5 because it appears the most frequently, 3 times. Alright? Everyone else okay so far? Good. Have a go at that then. Determine the mean, the median and the mode for that set. Right, gents, I'm not going to add them all up but write them all out. What's the sum of all of those? That's over around. It is, add them all together. Yeah. And there are 13 of them. So the mean is 5. Yeah. The median, have to put them all in order, so we've got 1, 2, 3 lots of 3, 2 4s, 2 5s, 2 7s, and 8, and 13. And that's the middle value, so the middle value must be the 1, 2, 3, 4, 5, 6, 7th value. And the mode is the most occurring value, so that must be, one has 3 of them and only 2 is any of the others, so mode is 3. Yep. Okay. And the second one, mean is, so it's x bar is equal to sigma x over n. Sigma x in this case is well, yeah, you could add them all up and get a total and then divide by the number of them, so something over 6. So the mean value is remember, when you've got some units, you need to make sure that you state them with your answer. Alright? Median value if we rank them, we got 18.92, 27.9, 34.70, 39.68, 47.6, 0, and lastly 54.60. We've got an even number in the set, so we need to take the halfway point between those two. So we do 34.7 plus 39.68 and divide it by 2. And what did you get? £7. Yeah, so no real discernible difference there between the mean and the median. 1 penny. Alright? Everybody okay with mean, median, mode? By the way, I just realised something on the front page that I didn't edit out. We are doing median mode for group. I haven't got a cover. Median and mode will only be doing the mean for group. Well, can't help that. Okay, so moving on to the mean of group data. Mean value for a set of found by determine the sum of the frequency times the class midpoint values and divide them by the sum of the frequencies. So that the mean value for a set of group data, x bar, is, and then we take frequency of the data in group 1 times the midpoint value in group 1 plus frequency in 2, midpoint value in 2, and so on for n number of values or n number of groups, I should say, and then we divide that by all the frequencies in those groups added together. And the most succinct way of writing that is x bar is equal to sigma f times x over sigma f. All right, where f is the frequency of the class having midpoint value x. All right. So, have a look at this problem together. Frequency distribution for the value of resistance in ohms of 48 resistors is as shown. Determine the mean value of resistance. So we've got our classes here, and I've split it into values top and bottom of class because it lends itself to using a spreadsheet here eventually to do these kind of things. Alright, so what we need to calculate is the midpoint between each of these top and bottom values and record them in that column. Right, so I'll give you about a minute to do that. In good old Blue Peter fashion, here's one I done earlier. Should have 20.7, 21.2, 21.7, 22.2, 22.7 and 23.2. Yeah. So like I say, pattern to them. Everybody get that? No, Pi? Well, Pi, just the quickest way, if you can't see it easily, is the higher number, take away the lower number, divided by 2. And add on the lower number. It's the difference, half the difference added on to the bottom. Right. So, gentlemen, this column is this frequency times the midpoint. So frequency times midpoint. So we got 3 20.7s. So we do 3 times 20.7, put it in that column. We need to do that all the way down. Right, gents, again, find it. There is what you should have. 62.1 for the first class, 212 for the second class, 238.7 and so on. Why do you add them all up? Because the mean value, hang on, just let's label these. This is the F, these are the F values. Yeah. These are the X values. And this is F times X. Yeah. And our formula, remember, is for group data, X bar is equal to the sum of X times F over F. So we sum up this frequency times midpoint column, put that on the top, 1052.1, and divide that by the total of the frequencies, which is there, 48. And we end up with a mean of 21.919, which is equal to 21.9 ohms to 3 significant figures. Again, we should remember that this question has units associated with it, the ohms of resistance, and therefore they should be included with your answer. All right? All happy with that? Yeah. Okay, standard deviation of ungrouped discrete data. The standard deviation set of data gives an indication of the amount of dispersion of members from the measure of central tendency. So we looked at these measures of central tendency this morning, mean, median, mode, at least for ungrouped data, and the mean of group data. Standard deviation is a measure of how far in general the data goes, spreads out either side of what is that mean, median or mode. What it is it's the value is the root mean square value of the data, and you obtain it as follows. You determine a suitable measure of central tendency. So you find first either the mean, median, mode, that data depending on which is the most suitable. In case of what I asked you to do, you'll be told which one to use. Okay. Calculate the deviation of each set member from the mean. So we calculated the mean x bar. We take x bar away from each of the individual values in the set. We're talking about ungrouped data here at the moment. Okay. We then square each of those. Can anyone think of why you might square them? What the issue is there? And why each of those differences between them squared? What we're gonna, when we calculate these values in 2, some of them, that one might be 3, second one might be 2, but the third one might be -2. Yeah. If we take the square of that, and the square of that, and the square of that, what happens? What are the results of doing each of those? 3 squared is 9. 2 squared is -2 squared is, it gets rid of the negatives. Remember, we want to know is essentially the average distance of the values from the central tendency. And if you kept negative values, it would it would bring the result closer, and you don't want that. You want it to be a genuine, how far in general is it away either side of the central tendency. So by squaring each of the deviations, we'll get rid of any negatives. So we got the sum of these squares that we then find the total of. So we add them all up, and then bearing in mind we are group at the moment, we divide it by the number of values in the set. And then lastly, take the square root of that. So we're then cancelling out the squaring that we did over here. That square to the values, math, then take the square root of, so it's the root of the mean square. Alright, and you've heard that already in the AC science. It gives you that average DC value of an uniform root mean square. Alright? So we can explain of and we use the Greek letter small sigma for that. So sigma is the square root of the sum of the deviations squared divided by the number in the set. Sum of the deviations divided by n. So x is a member of the set here. X bar is the mean of the set, and n is the number of data of the set. Here I should qualify x bar as it's whatever measure of central tendency you choose. So that could also be the node or the mean. Okay with that, everyone? There we go. Very simple, understand. Right, what we're using here, determine the standard deviation from the mean of the set of numbers 5, 6, 8, 4, 10 and 3 correct to 4 significant figures. what we got to do first? We're using the mean as the measure of central tendency. So how do we calculate mean? Yeah, so sum of x divided by how many of them there are. That's 36 and 6. So x bar, the mean is 6. Yeah. So this standard deviation is square root of the sum of x minus x bar squared over x. So what we got to do now, we need to find the sum of the differences squared. Yeah. So we've got 5 minus 6 squared plus 6 minus 6 squared plus 4 minus 6 squared plus 10 minus 6 squared plus 3 squared. So add all them up. So that's going to give us the sum of, and give us that top line there. Just summing that up for you, okay? Here we've got a set of data 5, 6, 8, 4, 10, 3. Calculated x bar, the mean 6. The formula for standard deviation is the square root of the sum of all the differences squared divided by the number of data in the set. So this line here finds the sum of all the differences. So this 6 keeps reoccurring in here as the x bar value. We square them to get rid of any negative values. That was found to be 34. And we divide that 34 by the number of values in the set, 5.6 reoccurring. We then take the square root of that value to find the standard deviation. So the standard deviation for that set of data, based on the mean as the measure of central tendency, is 2.380. Yeah? You're looking confused. Standard deviation for group data, use the following formula. Are we listening? Very similar, but if you look at it, the differences x minus x bar squared in the top line are all multiplied by the class frequency, the relevant class frequency. Yeah. and then divided by the sum of the frequencies, and then we take the square root of that result of all that. So f is the class frequency value, x is a class midpoint value, x bar is the mean of the group data, which we learned how to calculate earlier. The method can be demonstrated using the same data as the previous problem. So where we calculated the mean earlier of the group data, we're going to use that data to calculate the standard deviation. Yes, there are statistical functions on the calculator. I'm not covering that. If you want, well, you can check your answers that way. But in an assignment, I'm probably going to be requiring you to show the method or show you can use a spreadsheet to do it. All right? Yeah. So here's our data from earlier, where we calculated the mean of the data given there, the 48 resistors, to be 21.919. Okay, so what we need to do is calculate the differences in this column, square them in the next column, and multiply them by the frequency for the final column, and then we need to total up that final. And we need to total up the frequency column, which we did before, that was 48. Okay? Because we are looking to have all what you need to do is make sure that you've got the negative sign inside the brackets. Yep. Because otherwise what it's doing is using literally the laws of precedence, which says they do squares first. So if you're trying to take the square of -3, what your calculator is doing, if you just put -3 and then square it, is it will square the 3 first and then multiply by -1. Whereas if you put the negative sign in the brackets, it will square the negative number. Alright? That column there are the x values, the class midpoint values that you need to use. And x bar is this one down here. Take a look. So this column here, the x minus x bar column, should look something like that. Squaring those values should look something like so. And then multiplying those squared values by the class frequencies should look something like so. Yeah. And then if you look at the formula here for standard deviation, the top line requires the sum of all the differences squared times the frequency, so the sum of this column, 19.953, and then the sum of the frequencies to go on the bottom, and then we take the square root of that fraction to end up with a standard deviation of 0.645. Sorry? What do you disagree with? This one? This one? You got those two values the same as me? What's happening there? Okay, I won't worry about that, because what's happening there is I actually used a spreadsheet to calculate these, and I'm going to show you that in a minute. Okay, but although I've restricted it to 3 decimal places, the spreadsheet still uses the full resolution. So there might be slight differences because you're rounding here. I'm looking as though I'm rounding, but I'm not actually rounding. Okay, so don't worry if you're a little bit different. But are you within a small amount of the result I got there? What result do you get with that difference? For this result down here. Okay. Oh, that's significant. How much difference do you got here then? Are they all different? What have you got here in this column here? What? World cut, yeah? But 5.17, so you rounded that. Do you see what I mean there? Yeah, divided by 48, because that's the... If you do what? This one? Where are you getting that figure from? Yeah. Yeah. Hang on a minute. Okay. Have you square rooted it? You've got a square root of it. Guys, when you've added all this up and got that value, that's the top line. That line. And you got the result of that 0.4 of it. So that's the square root of your 0.4 whatever. Are you then close to 0.645? Yeah? Right? You see what I mean, Connor? Yeah. 0.4 as compared to 0.6, there's a significant error, isn't it? You know, that's 0.2 error in 0.6. That's a lot, right? So it don't seem very much in size of number, but you've got to take into account how big your numbers are in the first place. Right? If we were talking about 400 in a million, then that wouldn't be significant. Do you see what I mean? Yeah? Alright? Right, what I'm going to do is how that process can be simplified using a spreadsheet. So what I've done is I've put my data in these 2 columns here, and the frequency in this column, This column here is calculating the center value. So I've taken the data in B4 and added to that C4 minus B4 divided by 2. So that column's finding the mid-class points. Now I can then stretch that formula down, and that'll do that for all the cells in that column. We then want the frequency times the midpoint, so we go equals frequency value times as the star on spreadsheet times the midpoint value in there. Once I've done that formula, I can stretch that down for all columns. Have I got that right? Is that the same? Yeah, then we want the x minus x bar value. So what I did on it, what you can do there is if we take this mean value that we want to use lots of times, that was 21.919. We want to do this value minus that value in every column. So if we do equals midpoint times frequency minus, click that one, and then if you press F4, notice you get $1 in front of the E and $1 in front of the 13. That means that's absolute, and when you copy that formula, it will still reference that one cell. Yeah. So every time, if you don't put that in, it will try and reference different cells when I copy that formula across. If you look where I put the $, in, it means it references that cell for every one. That's absolute. You can also just fix the column if you want to, or you can fix just the row as well, depending on what you're trying to do with a particular set of data. But if you've got one value that you want to keep using in lots of use an cell reference for it. And in this column, we want to square all the values in here. So we put equals that value raised to the power of 2. That's how you do that. Oh, what have I done here? Is that better? One for this one is that dollar times frequency. Take both of those down to the bottom. Yeah. And we want to sum that one, don't we? Yeah, function auto sum. Sum the whole column up. Yeah. And then the standard deviation equals square root that value divided by that value. You love it, do you? There you go. So the spreadsheet makes that process. Any more data than we have there, calculate a manual way would be a bit cumbersome, right? So it might be that I'll ask you to do something the spreadsheet way. Just see what else. Depends on how much data it is. You hate the what? What I suggest you do is some of the problems I'm leaving you to do now on the coming pages, you have a go with the spreadsheet and stuff, alright?